Then forgotten to. I want to give you some examples. I'm trying to avoid trigonometry. So let me look for an example that has multitasking. I'm having several screens, so kiona nimekawia, si ati nimepotea. Naelewa? Natafuta maswali kwingine. And being a mathematics teacher, well, I want you to do this. The integral of 2v cubed, integral of 2v cubed dv, the integral of 2v cubed dv, then the integral of 12 over z raised to 5, 12 over z raised to 5 dz, 12 over z raised to 5 dz. And then the last one is the integral of x squared plus 1, the integral of x squared plus 1 over the square root of x, over the square root of x, over the square root of x dx, over the square root of x dx. Integral of 2v cubed dv. The second one is the integral of 12 over z raised to 5 dz. And the last one is the integral of x squared plus 1 excuse me, over x over the square root of x. X squared plus 1 over the square root of x. Who wants to go first? Who will go first? Kevin?
I have v raised to 4.
The first one is 2.
I have v.
I have v raised to what? Raised to 4.
dv.
No,
dv.
you are not supposed to add dv. We are differentiating with respect to v. So avoid dv and add a constant. Add the arbitrary real number. So it will be a half v raised to 4 plus c. Usisahau kuweka c. When you are integrating, that's when we use the dv. Are we together? So your answer should have an arbitrary real number. That's correct.
Repeat the last part.
I'm saying when you are integrating, let me share. Let me share my screen. That's the challenge now of these mathematical units being in the being in the online. It's easier when you are doing. Can you see my book?
Yeah.
This is what I've given. This one. I've said we are integrating 2v cubed dv, right?
Yeah.
I take my 2 outside the integral sign. So I'm left with v cubed. So if I integrate v cubed, I add 1 to the power. So I'm going to get v raised to 4. Then I divide by the new power, isn't it? Then I bring my 2 back. So I'm going to get 2v raised to 4 divided by 4. I simplify by 2, 1, by 2, 2. So my answer will be v raised to 4 plus c. Or rather, I have v raised to 4 plus c. Right? We go to the second one. 12 over z raised to 5 dz. So I'll take my 12 outside. I'm left with z raised to negative 5. I've just put it in this form for easier doing. So I add 1 to the power. Negative 5 plus 1 is negative 4, isn't it? I divide by the new power, which is negative 4. Then I bring my 12 back. So by 4, negative 1, by 4, I get 3. So my answer becomes negative 3 z raised to 4 plus c. Don't forget the arbitrary whole number. Don't forget that arbitrary whole number. It is our constant of integration. Look at the number 3. I want you to try and absorb. I don't know whether my screen is. Let me try to make it bigger. You can now see better, isn't it? It's now better.
Scroll up,
Yes.
scroll up a bit.
You? I scroll.
Scroll up a bit.
Okay. That's okay.
Yeah.
Can you make it even? I can make it even bigger. It is now better. So what I've done, when you see the square root of x, this same as x raised to a half. A number raised to a half, it's its square root. You know that, isn't it? Mathematically speaking. So I just split them to be in the form of what you are talking about. So I'm going to have x squared over x raised to a half plus 1 over x raised to a half. So that I work on them separately. It will be easier if I do it that way. I want you to absorb. So tuko sawa? Kuna mtu amekwama?
Yeah, kwanza niko sawa. The second part. The
Which
3 over
part?
2.
This
The
one,
second part.
3
Yeah.
over 2.
Yeah.
What's the challenge? My x is raised to 2, isn't it? This one, the one that is upper.
Yes.
Tuko sawa? Nikipeleka ex yangu huko juu, it will be raised to negative a half, isn't it? So nitabaki na
Okay.
1.5. 1.5 written in improper fraction is 3/2. Umeelewa sasa?
Yeah.
Yeah, my x here is raised to 1/2. So if I write it nini as a reciprocal, it will be x raised to -1/2. 2 minus 1/2, I'm going to be left with 1.5, isn't it? 1.5 is same as 3/2. Plus now I take this one, the reciprocal will be x raised to -1/2. Then from there, I now integrate. I add 1. If I add 1, it will be 5/2. I divide by the power. I add 1, it will be 1/2. I divide by the new power, plus c. Right? This new power, you cannot have a fraction and a fraction. You just multiply by its reciprocal. So it will be 2/5, x raised to 5/2, plus now 2 multiplied by 1/2 plus c. Tuko sawa? Absorbed? I want to share the last rule. Then we call it a day. I have so many windows.
Please share those documents, Mwalimu.
Yes?
Please share the documents, the ones you showed us
Yeah.
from the book.
I'll share the documents, no problem. I'm multitasking, so you'll allow me to go open the. You can see my screen now, right? I want to show the last rule for the day. And this is a case where we have two functions. I have the integral of fx, I add g of x. So these are two different functions. Or I have the function of x, I negate or I minus the function of g. When you have such a presentation, or when you have such a unique case, this is how we go about it. So you have the function of x plus that function of gx. We just split them and work them differently. So I'm going to split them. I work the function of x separately and the function of g of x separately. Then after doing that, I get the answer. An example. Forget about the trigonometry. For example, I have such a equation. We have such a equation. So I have 3t raised to 4 plus the square root of t. So these are basically two functions that I'm adding together. Yeah. So I'm going to split them. I've said t, the square root of t is same as t raised to 1/2, then work them separately. And this is what I've done. So I've taken them separately. And remember, we are going to take our 3 outside the integral sign. So this one does not negate the former rule. So our 3 will be outside the integral sign, then we work this. So this will be t raised to 5/5. Then I bring my 3 back. So it becomes 3/5t raised to 5. Plus, this is t raised to 1/2 t, right? Are we together? So that will be same as t raised to, this is t raised to 1/2 plus 1. It will be t raised to 3/2 or 1.5. Then I divide by 1.5 or 3/2. But now 3/2 cannot be below the another fraction. So I multiply by the reciprocal, I get 2/3. Are we together so far? Then I add the arbitrary real number c. I'm waiting for you to sync. Maswali. Kevin,
Tujaribu kwa example.
najaribu kuelewa.
Na example.
Okay.
Or where you divide by the power, you reciprocate, you say 2/3.
Exactly.
Oh, okay.
Exactly. Yeah, I get the reciprocal.
Okay.
We are good.
Yes.
So I'm going to share the notes in the portal, and I'm also going to share a few questions for your practice. Okay. So next time we'll be looking at the applications. I don't want to introduce exponents at this stage. We are going to have the exponentials at the later stage. So enjoy your evening. And kindly do a lot of practice. Get any book, get any question, try to do these things. Practice makes perfect. Is sawa.
So
So enjoy your evening.